I think the most important thing is that, while we sit here and as data scientists in rooms and try to build models, I think the real people who must be saluted in part of this whole, in this whole context of COVID are the people who are out there in the field doing things and fighting this battle. And this is certainly, and I think that we must remember why we are trying to do this, if we can actually try to build something that's useful for people in the field. So first of all, I'm just going to have about a presentation for 5 to 10 minutes, where we're going to talk about what is actually there in this model. And then we're going to spend a significant amount of time actually in looking at playing with the model itself and understanding the kinds of insights and knowledge you can gain from the model. And so therefore that's going to be a majority of the discussion today. And then maybe if time permits, we're going to talk about some of the visualizations and interesting visualizations that can be done with this data. And finally, we'll talk, maybe have a few minutes talking about the specific cases and prognosis of, where things are going to go. So I want to also, I think we've mentioned that. I think Chatham House rules is important, and I think it's, so therefore I'd like to make sure that that's something understood by all the participants here today. Let's talk about the assumptions of this model. This model is actually based purely on publicly reported data. And I think this is something which is important. And one of the interesting things is that more so probably than in any other time before, there is more publicly available data that is that can be used to build interesting models and assumptions, and as compared to in India certainly in the past. And this is purely based on publicly reported data. And so therefore our model is only as good as the publicly related data. The other part about the model is it's a model that is optimized every day. So whenever there is new data and new evidence, our model actually gets optimized as a result of that. The other thing is that while this is a model which talks about COVID, which attempts to predict what is happening in COVID in the entire country, it actually runs in a granular manner. So therefore, it actually runs at a district level, it can run at a state level, and then these models are aggregated in a networked fashion, okay? And that's in a networked fashion to actually generate predictions for the country. And the other thing about it is that fundamentally our goal is we provide 15 to 30-day predictions on an ongoing basis at a district, state, and country level. And the most important things, and lots of people have predictions for various reasons. The main reason that we are attempting to predict things here is to actually do something actionable. So the absolute number is not important. In fact, if we have an absolute prediction that things are actually not going to go bad, we actually hope that we make an intervention and we actually prevent that from happening. So the absolute prediction is not important. It is the trends that we want to see from these models. And then finally, of course, the model, we predict 15 to 30 days in the future, assuming status quo. But of course, things change and interventions can happen. And that can actually change the course of things. And if there's anything that we've learned about COVID is that things change. It's something that's good today may not be good tomorrow. It's something that's good, it's not good today, may get much better tomorrow. And in addition to this standard model, we've also created a do-it-yourself model. So therefore you can take your own entity and build a model for that specifically if you want to as part of this. So then what do we predict? We actually make predictions for every state and district in the country, 15 to 30 days into the future. And now there's nothing in our model that prevents us from going further than that from the mathematics of the model. But actually the reality is that you actually have better predictive power in 15 to 30 days. And it also gives you an action of something you might want to do as a result of that. And what are the things that we predict? We predict the number of cases that may be there in a particular place. We predict the hospitalization requirements of a particular place. And we predict the fatalities that given our trends that might happen in the next 15 to 30 days. In addition to that, we provide a bunch of insights which are at the state or district level. The first thing is the transmission rate. Most people who've been with COVID probably know there's something called transmission rate. Is if a particular person is infected, how many other people do they infect? And this transmission rate is very important for the transmission rate to be less than 1. And if it's less than 1, then overall, over time, over time, the number of cases will reduce, over time, and whenever the number is greater than 1, it means that the things are growing faster. The two more interesting things that we measure is we measure the positivity rate on a daily basis, which is basically the percentage of the new tests that are actually new cases in the past 5 days, which are positive, as a ratio of the number of new tests which were done in the past 5 days. And the other thing which we do is we calculate the mortality rate, and we calculate it a little bit differently than other people. We actually calculate the cumulative deaths till date, but we divide it not by the cumulative cases today, but we actually divide it by the number of cumulative cases till 15 days ago. And the reason why we do that is actually there is that lag, that mortality is a lagging indicator in the model, and that's why we actually do the. So then how do we use the models? And I think that's where we're going to spend time. The question may be, if I am at a particular district or a particular state, how many hospital beds will I need in 15 to 30 days? Are we under testing in this particular region, right? And then the interesting thing is the model itself. Now, there are obviously lots of things which are, and we will talk about those places. Obviously, everybody knows about Mumbai and Delhi and Chennai as hotspots in the country. But that is actually, they are there, and there is action going on. But can we catch things early? Can we understand where there might be a problem and fix it? So therefore, the best thing for us is that if someone actually uses it to change the reality and actually make our model predictions wrong, okay? And what do I need to do from an action perspective, hospital beds and things like that? Okay, so, and I think that, and I think there are lots of things we actually have. It's known as a modified SEIR model. We actually do lots, and SEIR is one of the popular models for modeling this. We have other features such as age-wide segmentation and this network aggregation capability. And then we optimize the parameters of this model every day based upon the raw data that we receive. So without further ado, I'll probably move from the presentation to actually show the model and try to show the model and explain. So on the left-hand side, you basically see a map of India. And the map of India, this looks very similar to, and then in there, you have information about the number of COVID cases in every state in the country. And it's interesting that we actually predict, we actually have 3 numbers in a given state. For example, right now in Maharashtra, we see the number of cases that are there in the state as of today. The second one is we have a rate of transmission in the state. And then, of course, we have the total population of the state. These are the 3 pieces which are there for each state. And the color of the thing actually depends upon the rate of transmission. So if the rate of transmission is green, that means it's probably less than 1. And if the rate of transmission is orange, it's kind of around 1. And if it's red, it's significantly higher than 1 at this point in time. Things change from time to time. So therefore, the color coding is a size, depends upon the number of cases, and the color coding actually tells you how fast the transmission is happening at this time. So now let's look at the numbers.
That everything that you're going to cover now is available on the website, which we have now made available to the public. Earlier, it wasn't available to the public. It is now from this point onwards available to the public. The link is in the chat session. So you can play along with the website if you like.
The main goal here is to actually play with the website and ask questions based on that. So then I think, so here I'm right now, so therefore now in this, if I'm looking at down here, on a daily basis, we can actually have, there are 4 things or 5 things we predict. the number of, predicted infected, the number of people who are hospitalized, and the fatalities on any given day. And the way that the optimizer works, and then we also have a reporting of the number of infected people. So therefore, the reporting of the infected people is actually matched with the prediction up till now. And then given that, you actually move into the future. So therefore, there are three important lines here. The first line is 16th June, that is today's date. The second line is the 2nd of July, which is 15 days from now. And the third line is 17th of July. And then if I look at the model tomorrow, all these numbers would move from there. So therefore, at a very large scale thing, basically what it's saying is as of 16th June, we have basically, as of 16th June, we have a 350,000 cases in India, which is actually the number of, which is very close to what is being reported. And we have a prediction that basically in about 30 days, we are going to go to about 7 lakh cases in India. And the transmission rate is actually 1.09, which is actually quite close to 1, but it's still a slow increase is what we see in our model at this time. And in addition to that, we had talked about the mortality rate, where we are doing actually something slightly different from others in the sense that we are dividing by the cases 15 days ago. So the mortality rate is about 5.76%. And the positivity rate of all tests in the last 5 days, about 6.9% of the tests are actually positive. So this is what we are seeing as far as India is concerned. Now, I think this is not, there's nothing that's that unusual. I think a number of other people are predicting something very similar. And because at this stage, but when it gets interesting is when you start going into cities and see. So I'm going to start with, for example, click on Tamil Nadu, and we're going to see the situation in Tamil Nadu, and we're going to look at Chennai, right? So Chennai is interesting. So therefore today we see that Chennai has about 34,000 cases with 34,000 cases. And we have the number of people who are hospitalized in our model is showing to be approximately 4,900. Now, if I move 30 days from now, what does that show? The number of infected has moved up to 85,000, but that's not the more important thing. The actual number of hospitalizations has increased from 4,900 to about 11,000. So therefore, if you look at it, basically we're saying is that we need 6,000 additional hospital beds in Chennai in the next month to actually account for the, Now, obviously in Chennai, people have known for a while that the numbers are high. So therefore, everybody knows about what to do. So now let's take another example like Delhi. And so the other thing, the rate of transmission in Chennai is 1.15. And that's actually greater than 1. So it's going to be increasing, but the mortality rate is also low. It's about 2.53. So now let's move to Delhi. Now Delhi is slightly, so Delhi, I think we look at the state itself because district-wise information in Delhi is actually not properly reported. And districts in a city like Delhi anyway are not that important. So the interesting thing is the rate of transmission in Delhi is much higher. It's 1.3. So cases are increasing faster in Delhi. And two more things that you see here is the mortality rate is 8.3%. So 8.3% of all positive cases 15 days ago have resulted in a mortality. And the positivity in Delhi is actually almost 32%. And that's obviously something, so therefore when the mortality rate is high and the positivity rate is high, you know that the real number of cases are actually much higher than what is reported. And also it shows up, in hospitalizations again, you see that we have about 6,000 hospitalizations required today. And literally in a month, it's probably going to become, the model is showing about 18,000 hospitalizations required. So now let me take a third example, and just after that we will move to other things. I'll take a third example, and we'll look at Mumbai. And so Mumbai is interesting. Please notice the shape of the graph. In Delhi and in Chennai, that the lines were actually going up. In Mumbai, the line is actually flattening, and that's interesting. So therefore, the Mumbai, the line is actually flattening. And if you look at the number of hospitalized required today is about 8,600. But if I go 30 days from now, we see that the number of hospitalized required is actually 7,600. So you actually reduce, and actually if you go and you click on just the hospitalization, you see that place like Mumbai is close to the peak as far as the hospitalization requirement is concerned. And given the data, our prediction is actually hospitalization in Mumbai will go down. So therefore, this is an example of different kinds of stories. And I think that if you've been following the news carefully, the story about Mumbai or the story about Mumbai or the story about Chennai or Delhi are actually fairly well known. And our model actually is consistent and actually has similar predictions to what somebody, what you might think might happen. So now let's see where it gets interesting. So therefore, but this tells you how to play with the model. So now if I have my own district, I can choose my district and see what it is. But now I'm going to actually say, let's talk about some things that are going to happen in the, some things which may not be completely obvious today. So, okay, so now I'm actually going to go to the country and I'm going to try and see what are the places where I will need the maximum number of additional hospital beds. Okay, we talked about Delhi and we talked about Chennai. We knew these two, we talked about them already. The interesting thing in the country, the third place where hospital beds might be needed is Thane. Thane, of course, is a suburb of Mumbai. So it's interesting that while the Mumbai city is getting better, there is probably a need of hospitalization beds in a place like Thane. So I can click on Thane and then I'll get the model for Thane. And therefore I can understand that at Thane, that the prediction is that you will probably need 2,700 beds in Thane in the next 30 days. Or going down, you have Hyderabad. Now this is another metro. Now in Hyderabad, people don't talk much about Hyderabad, but when you click on it, you see the shape of the graph in Hyderabad, that there is a significant increase that is predicted as far as the model is concerned in Hyderabad in the next 30 days. Or now you look at other things. Faridabad is interesting. Again, it is growing fast. It's growing similar to Delhi. So it's actually very close to Delhi. And therefore you see the numbers, its trend is very similar to Delhi. Palghar is actually a suburb of, it's close to the Mumbai metropolitan area. So again, when you see the main city, things are coming down. In the suburbs, things are rising. Or Pune, again, another metro. Gurugram again, because being close to Delhi. Some very interesting ones. Kargil this is actually very interesting. This is actually, and we have to see whether next few days, whether this thing actually continues or not. But we are actually predicting that there is a need for 700 beds in Kargil in the next 30 days. That's what the model is predicting. Or let's take an example of Bangalore, which so far has been actually one of the areas which has actually escaped. But there are early signs that in Bangalore also things are actually going to be, both the RT, if you see the rate of transmission in Bangalore is 1.69. Mortality rate measuring the way that we measure is about 9.52%. And so therefore we see that Bangalore is also another area where there is a concern and where you should not just be looking at things, but you should be looking at how am I going to deal with this, because there is a significant number of beds and other requirements that are there. Now I want to go from beds is actually something which is near term. Now I want to go back and say that I actually want to go and look at districts which have high transmission rates. So these are very early times where you are looking at districts where there is a transmission rate is very, very high. So even if the numbers are small, something dangerous can happen. And that's where people need to be aware early, look at the data early. And that's how our model is tuned. Our model is tuned not to be, it's not tuned for ultimate accuracy. It's tuned for actually telling you early what the trend might be. So for example, okay, Faridabad already came in there. We said it's 1.75. The transmission rate seems high here. This is going to be something that's going to be significant. And if testing is not there, we need to actually, again, you look at, that's a place where you want to do. We also have Lucknow as an example, where the same thing that we are seeing. We're seeing that as of now, the infection rate, transmission rate of Lucknow is increasing significantly. And that's a place where people need to look at. Or for example, the Krishna district, which is the Vijayawada area. Okay, so many of these places which are today not in the news, and today not being discussed. You know, they in this model, you are easily able to understand that maybe there's a problem. The model can be wrong, and we hope the model is wrong because somebody actually takes action and changes the reality of what happens in that case. So I think, so I think that this probably gives you an idea. Now you can pick any district, right? You can pick any district. Now I'm certainly in Andhra Pradesh, and we can just go to any district, and you can actually see the same things. You know, I want to find out what's the situation in Nellore. So I can pick any district in the country, and you will have a model, and you will have a prediction for 15 days and 30 days, and therefore you can take action from that in that particular district. Okay. So I think moving now from here, I'm now going to actually show certain visualizations and other things that are also there as part of our website. We'll as visualizations that are part of our website, and try and show certain interesting things. So the first one is interesting. Every day we publish what is known as a state-wise total infection. So therefore, it's actually kind of a way to understand which states are most affected, affected by COVID in absolute numbers. This is an interesting one. This is a district-wise infection thing. And it's actually interesting. And I would like to show 2 or 3 interesting states. I'd like to show Gujarat. It's very interesting, right? Pretty much all the cases in Gujarat are in the Ahmedabad district. While, and Tamil Nadu is also very, very similar, which tells you, again, it is the metropolitan area. Chennai dominates all the infections in Tamil Nadu. Now, if I go back and I see something Bihar, and it's a very different view. It's like we have few number of cases everywhere. Why does this happen? I think this happened. There may be many reasons. The data, and what you see is that look at the data, but what you see here is that it may be because of the migration. That when a number of the tests were done when the migrants went back to their district and when they got off the train, and therefore you have a very, very distributed sense. And now you look at UP; it also seems quite similar to Bihar in its. So the next thing is so this is, I think lots of people have seen have seen these racing bar charts for various things, but we've done something interesting, that we've actually implemented a racing bar chart of our predictions. So we are actually seeing how things move into the future. So therefore we are trying, we started off with today, and then we're talking about how the infections will move into the future. So therefore now, as I play this, you see that the states which actually have a faster rate of growth begin to dominate. So these are interesting visualizations that are available. This is an interesting one. This is a case where I am predicting the number of, I'm actually predicting, so let's see if I can start it. I'm predicting the positivity rate, okay? And it's interesting, at the beginning of in April and May, Maharashtra was always the state with the highest less of positive things. But now you see that suddenly Delhi is going to go past Maharashtra and become the state which actually has the highest rate of positivity. Now I'm going to, and today if you see, Delhi is by far the state with the highest level of positivity in there. Now, the other interesting thing is, if I actually use this same thing, and I'll play this once again, and then we'll look at Bihar carefully and see what happens to Bihar. So therefore, right now, you see Bihar is at 5%. Now it moves up to 7%, 8%, 9%. Now it's starting to come down again. And if I play all the way to today, the positivity rate in Bihar has come back down to 5%. And now it's sticking around that 5%, 5 or 6% for till today. Now, why would that happen? The interesting thing was that the time when the rate went up in Bihar actually corresponded to the time when migrants came back to the state. And so therefore the positivity rate rose and then it came down. So that's, I mean, what does that mean? We let others to interpret that, but that's basically saying that a significant amount of testing was done when the migrant workers came back to their villages. Now, this is another thing. We're showing the trend of positivity rate over time. And we see that, you know, literally you see that, Delhi started just, was as low as 5% on 13th of May. And today it's at 32% or 30%. So that tells you, and in reality is even higher, but, we actually average over some number of days to actually smooth the curve. This is a plot of the mortality rate. And I think if people have read the papers in the beginning, there was a large amount of mortality that was there in West Bengal. So therefore, in the beginning, the mortality rate was always the highest in West Bengal. But now we are seeing that the mortality rate is actually rising in a number of states. So when you look at the graph itself, you see as we play out in time, a number of different states, and clearly what happened yesterday, and that basically both Delhi and Maharashtra reported a significant number of additional deaths, actually increased their mortality rates significantly. So if we come to today, there's a whole bunch of states which are at 9 and 8% as of today. And moving to my last visualization, this actually shows the mortality rate over time for a few states, and both Delhi and Maharashtra had a huge spike yesterday because a significant number of new things were detected yesterday. So, I think now I'm going to move on to the next stage of my talk, which is actually talking about, we have, one of the things that we do have in our model is we actually have the ability where somebody can create their own model. So it's called a do-it-yourself model. So if you're not a district or you're not a state, we are not building a model for that. So you can build a model for whatever you want to build. So just as an example, you can actually run, and we collected data from newspapers and things like that. And we actually manually built a model, and we built a model for Dharavi, which we were interested in. And then the interesting thing is that, so therefore anybody can use data and build their own model and use it. And some of the interesting things that came up from the Dharavi model was that, we thought that the slums are the worst case scenario for COVID-19 because they are extremely dense and social distancing is not possible. And if we looked at the RT in April, the transmission rate in Dharavi was above 2. But today, Dharavi has a transmission rate below 1. And I think that's very important. That because now if I looked at my prediction would have said that Dharavi would be a bad situation later. But the truth is that work was done and virus was controlled in the toughest environments. And I think that's the positive message that we need to take, that just because there is a prediction which is saying that, in fact, we have to take our best to prove the prediction wrong. And this is just a graph of showing really what was the transmission rate in Dharavi over time. As you see in April, in most of April, it was plus more than 2 and between 1.8 and 1.9, which is extremely high transmission rate. And now, at least for the last 15 days, the transmission rate has been less than 1. And that's really the example. And finally, I want to come back to some little bit more larger questions, which is what is the prognosis? So what is the real number of COVID cases in the country? When will the peak in India be reached? What is the mortality rate in India? And I want to talk about some of these things in the context of seroprevalence studies. Okay. So we say, when will the peak in India be reached? I can certainly say it's probably not going to be reached in the next 30 days. So therefore, if that's what the model says. But as of now, we actually don't have visibility as to when that will happen. But you see specific states, you see specific cities having controlled things. But as a country, we actually can't say that when that will happen. What's the real number of cases in the country? And I think therefore, I think one of the important things that I want to talk about here is, and ICMR has done a seroprevalence study. Unfortunately, some of the things were probably not done the best way they could have been done. But the nature of the study is actually the most important thing, that will need to be done to understand what is going to happen with COVID, with respect to COVID in India. And what they tried to measure was two things. The first thing they tried to measure was the number of people with antibodies. An antibody means that you've had COVID sometime in the past. And they actually did a large study of 26,400 people in 83 districts. And then they came up with a thing saying that 0.73% of the population actually had, had antibodies. And they also were able to measure the mortality rate. You look at all the mortality rate numbers the model is showing, that's based on reported cases. And those numbers are important directionally, but an absolute number, 9%, 3%, none of those matter. The real mortality rate is much less than that. And they had predicted 0.08. Now, I know that this particular study may have some flaws, but the concept of what this study is really very excellent, because I think the seroprevalence studies, which measure two things, which is basically the number of people in the population who had COVID sometime in the past. And that measurement is very important because there is a large number of asymptomatic cases divided by, and therefore that will actually tell you what the real mortality rate is. Because if you know that many more people have gotten it, it's much, it's difficult. There is some undercounting of deaths, but undercounting of deaths is much less. And so therefore you can actually get a good idea about what the percentage and what the prognosis for the country will be with respect to COVID-19. So I think that I'd like to end my talk by saying I hope that you enjoyed this, and I hope that you will play with the model. And we look forward to feedback, and we look forward to feedback, and I hope it's useful for all of us as we plan as individuals or as public officials to actually take on this challenge. Thanks.